experience the reality. Right? That is why this experimental setup, what you are seeing here. Understand? You must experience the reality. So you can feel the truth. Now you see what I have got. I have got a concave mirror here. I have got a concave mirror here, and you can see there are three parallel rays of light. Can you see? Right. Okay. Now my friend Rajdeep is sitting here, and he is going to conduct the experiment. Okay? Okay. Now you pull the mirror behind. That is, now I am pulling the mirror behind. I am pulling the mirror behind means it is as if the object is. Students, in the last class, we have understood the concave mirror and the formation of image when the object is placed beyond the center of curvature C, between F and C, and F, between F and P, and so on and so forth. Okay, and now what you are seeing on the board right now is a consolidated diagram. Okay, what is this consolidated diagram? Let me explain to all of you. Okay, now you see that I have placed an object, and this object, that is extended object AE. I suppose you can all see this. Now AE is beyond C. This is C. This point is C, right? And I have placed the extended object here beyond C, right? And this is F. So as all of us know, and we have experienced in the previous class, the image of this, right? The image of AE should be between C and F, and you can see that the image is between C and F. I suppose all of you can see this, right? And then you see what I have done. I have actually moved this object from this position to this position. So I am just showing it by a new name. It is actually the same object. So the object is now moved at C. Okay, and I am giving the name of this extended object as BG. And it is exactly at the center of curvature. So as expected, you can see its image B dash G dash. Now before I proceed, I hope you can understand the ray diagram. See, when the object AE, I have drawn a ray which is parallel to the principal axis. And definitely after, as per the laws of reflection and the rules of drawing, etc., whatever we have learned in the previous class, this ray is passing through the focal point. Okay. Then I have taken one more ray. You can see this ray, pinkish color ray. It is falling at the pole, and then it is getting reflected, and then the reflected ray passing through F, and this is meeting at this point. So you get the image of AE as A dash E dash at this point. I suppose all of you noticed it. Okay. Now similarly, when I move the object closer to the mirror and it is at C, now consider this ray parallel to the principal axis, and after reflection, well, you can see that it is coming back like this, and then I have taken one more ray, this yellow colored ray. So after reflection, it is meeting at this point. So we are getting an image exactly at C when it is at C, as expected. Then we are moving it further down, closer to the mirror, and now I am naming the object as DH. So again, you see this ray parallel to the principal axis, the same ray is returning, and this green color ray, which is falling to the pole of the mirror, after reflection, it is going and you are getting the image. So, so that's how it is formed. And then between F and C, you can see this ray parallel to the principal axis coming like this, and then another ray going to the pole, and then reflected ray like this, and you can see both these rays are divergent rays. So when I extended it backwards, they are forming a virtual image J dash K dash, which is erect. Okay. So now, what are our observations? What are our observations? So as the object is moved closer to the mirror, okay, from this point, the image, as you can see, is moving away from the object. I hope you can see this. Hello? Right. So you can see as the object is moving towards the mirror, the image is moving away from the mirror. Point number 1. And as the object is moving closer to the mirror, see, I maintain the size of the object C. As the object is moving closer to the mirror, the image, the size of the image is what is happening. See, this is the size of the image here. When the object is here, the size of the image is this. When the object is here, the size of the image is this. You can compare these three images: A dash, B dash, B dash, G dash, D dash, H dash. The size of the image is increasing as the object is moving closer to the mirror. These are very important observations. Okay, and of course, when you move it between F and P, then you are getting a magnified image, and that is virtual, because the rays are actually diverging. This is a point of convergence if we extend the reflected ray backwards. So, my dear students, I would like all of you at this point to pause and think about what are all the physical variables that are to be considered. I repeat, physical variables. So, think about the physical variables here for a moment. The same diagram, but without the graph paper. Okay, so that the vision is clear. Nothing more than that. So, what are all the physical variables? Okay. Now, you notice, student, that the object distance u is one of the physical variables, and then you can see the image distance v is another physical variable, and f is also a physical quantity, but for this setup I am using the same mirror, and therefore this focal length is fixed for this experiment. If you change the mirror, then the focal length will also change, and obviously things will also change. So we have now primarily identified three of the physical quantities u, v, f, where u and v are variable. Can you find some other physical quantity which is varying? Yes, I can hear you that you are telling the size is varying. So now you see here we are going to cut, because these are all linear extended objects. So what matters is the linear size, and in this case I will consider the linear size of the object as the height of the object, and the height of the object above this, so I will call it as HO, H suffix O, and obviously the height of the image H suffix I. So therefore now we have got 5 physical quantities U, V, F, HO, HI, of which U, V, HO, HI are the physical variables. F in this experiment is constant. Okay, so now what you see here is, you please appreciate it. As U changes, what will change? As U, that is the object distance, changes, then the image distance will change. Right? So therefore you see, and similarly as the U changes, what about the size of the image? As U changes, the size of the image will also change. Of course, the position of the image is changing as well as the size of the image is changing. See, these are the keen observations. That is what you need to do, and I suppose you have understood this, right? Okay. Any questions here? Well, yes, I have in this diagram, you see, I have removed all the rays corresponding to this object, etc. I have only retained this for the purpose of clarity. Otherwise, there is going to be a lot of clutter. Okay? And I have also included these two angles. You can see both these angles are theta because it is getting reflected at this point, and now the principal axis itself becomes the normal to the image. Okay? I hope it is clear. Right. So now our task is now, because you see, please understand, I have demonstrated an experiment. In fact, I have made you to conduct an experiment, and you have moved the object to and fro. You have observed the image. So now experimentally we have understood that the object size, the image size, the image distance, object distance, etc. are all related. Okay. Now the next task is, there should be some means for us to, do the analysis. So this is the first step towards analysis. What we experimentally experienced it, I have put it in the form of a diagram. Okay, and whatever experience we had in the experimental setup, right? The same experience we are having it with the theoretical setup. You can see I have represented it properly. So you must follow these rules of representation, and then you see you can start correlating between the realities and the science or the theory that is developed. Okay, so you should not learn the theory separately or something separately and all. So it's all interrelated. Okay, our next task is, we have identified that U, V, F, H, O, H, I are interrelated. Now our next task is, what is the interrelation? What is the interrelation? That is our next task. Okay, so we proceed to find the interrelation between them. There are 5 quantities: H, O, H, I, U, V, and A. These are the 5 quantities. Now, from whatever experiment we have done, and even the practical experiment and the theoretical experiment, what we have found is that V, what is V? The image distance V, image distance V is what is V? V is A or V is, or V depends on what? It depends upon U and A. Right? So this we write it as V is equal to some function. I'll tell you what is the meaning of function. Right? Some function phi 1. This is the name of the function. Phi 1. Some function phi 1 of U and A. Now let me explain this function for all of you because it is new to you. See, function means relation. Okay. Now observe this graph. All of you, please observe this graph. Okay. So this is the x-axis and this is the y-axis. I think you are familiar with this. It's not that it is entirely new. Okay. Now you see the relation. See, x is a variable, y is a variable. So here x is a variable, y is a variable. Right? Now supposing the relation between x and y is like this. So if x value is 0, y value is also 0. If x value is 1, y value is 2. If x value is 2, then the corresponding y value is 4, and so on. So I will get these points. So this point corresponds to x is equal to 0, y is equal to 0. This point corresponds to x is equal to 1, y is equal to 2. This point corresponds to x is equal to 2, y is equal to 4. I suppose we are able to grasp it. Okay. Now, if I join these lines by a smooth curve, I am going to get a straight line like this. I am getting a straight line. Of course, it gets extended. Okay. I think you are familiar with something like this. So here you see the value of y depends upon x. So y depends on x. Okay, I think you are convinced. So in this case, you see, we call x as independent variable. Independent means you can assign any value to x. But y you can't assign any value. Okay, y value will depend upon x. So this becomes what? Dependent variable. This becomes dependent variable. You will learn more about this in the mathematics class or physics. What I need, I am just explaining this. Okay, independent variable and dependent variable. This, whatever I have written here, this in the mathematical form, I'll write it as y is some function of x. See, this symbolizes what? Function of x, or y is related to x. This is the symbol used. It is not that this symbol into x. The name of this is this. See, I can give any name to this. I can give you your name instead of pi. I can write your name also. So what it means is it's a function of x. Now, in this case, if you look at the graph, what is the function of x? So, if you are smart enough, you will say y is equal to 2x. Please verify. You see, x is equal to 0, y is equal to 0. X is equal to 1, y is equal to 2. X is equal to 2, y is equal to 2. So, y is a function of x. What is the function? Y is in general, y is a function of x. And what is the function? Y is equal to 2x is the function. Did you understand, students? Hello? Huh. So this is relation. Huh. Now here you see that this relation holds good for the value of x greater than or equal to 0, because this graph is not defining anywhere for negative values of x. I suppose you are all appreciating this. Hello? Right? Huh? So that is precisely what I wanted to explain to you. Right. So now h, this one is a v depends on value this one. So here it is a different function. Here the function is different, here it is different. Okay, now here you see, now I have got hi. What is hi? Height of the image. Height of the image is dependent on what? Height of the image depends upon the object distance, the height of the object itself, and the focus. So this is another function, right? Name of another function. Now our job is to determine these functions. Our job is to determine these functions. What are these functions? See, what are these functions means, is v equal to u, is v is equal to u plus f, whatever it is. So we need to understand, we need to derive the relation, determine the relation. Okay, so that is our next task. Clear, students? So you have to understand, I'll give you some time, just look into it. Okay, then we shall proceed. I suppose you understood this diagram. Very important. You see, if my left hand is telling object image, right hand is showing the object. So you can see the image is here, the object is here. As the object is moving closer to the mirror, the image is moving away from it. Okay, see this, what is happening, you should be able to imagine it. See, in the numericals that you are going to solve, they will give you certain condition and relation. Now you have to study those relations and conditions carefully, and you should visualize, you should imagine. Okay, so that is where everything happens. So if you are able to imagine properly, the next thing is your imagination should get reflected in the representation. So once you are represented, then half the problem is solved. But this is where everything goes wrong in most of the students, because they are not able to imagine, visualize. So that is why you see I am trying my best to show you the realities by means of experiment, putting it here and making you to think and work. Okay, fine.